So we have with us Tina Peters, a graduate physics major from about 2 years ago. Okay, coming up on 3. Anyhow, with an interest in astronomy, she did some work with Professor Dame. She even managed to take a course here in astronomy for me that was just for her. We did a little bit of astrophysics, worked through a textbook, and she worked much more than I did. But she's been at Drexel for the last almost 3 years, and studying quasars. So Tina's going to tell us about what she's doing there, and besides that, she is a big part of the reason we have race walking at Ocean College. Here.
Okay, so hi, I'm Tina Peters, like you said, and so I'm going to tell you a little bit about my research, and we're going to start with just the basics. So what is a quasar, right? So even the physics majors here, you haven't had astronomy unless you make John teach it to you. So let's start with what that is. So the name quasar comes from the term quasi-stellar. So like a star, almost a star. Not really. What that comes from is that they were originally mistaken for stars. So what it is, the name quasar comes from the fact that it looks like a star. It's a point source in the sky. So you look up, you see a little dot of light, must be a star, right? If it's a fuzzy blob, then it's a nebula or a galaxy. In fact, that's not true. So these things, they look like a star, they're a little point source, but they're so far away they can't possibly be stars. So the first thing that teed us off to the fact that these things are weird was probably in the 1960s when they discovered that they have X-rays and radio waves and all sorts of weird things coming from them that's not really a star. Okay? So here's a picture of a quasar. So both of these are pictures from the Hubble Space Telescope. On the left, this is just a normal image, and you can see it looks a lot like a star, right? It's a dot. It has the little effects from the lens coming off of it. You would mistake that for a star if you first looked at it. But then they just block out the center part here, where most of the light is coming from, and you see that around this point source is a fuzzy blob. So what this actually is a galaxy that has a very bright point of light coming out of the center. And these things are so far away, they're like galaxies, they're some of the most distant galaxies that we can see, that all the light coming from the center part must be so bright that it actually outshines all the rest of the stars in the galaxy by 1,000 times over. And all that light is coming from something maybe the size of our solar system, maybe smaller. So this is something weird and new, right? Interesting enough that we want to figure out what is going on, okay? And what is going on is that that center part of the galaxy is what we call an active galactic nucleus, okay? But astronomers are bad at naming things, they just come up with really boring names. So it's an active galactic nucleus. So in the center of this galaxy, something is actively happening to produce all this light, okay? So these center parts are some of, you guys can't see what I can see. Okay. Well, there's more things under that. Anyway, in the center of the galaxy is this really luminous source, okay? The most luminous thing in the universe. It produces more light than anything else in the universe, and it outshines the rest of the galaxy by 1,000 times over. And we think what's causing that is a very hungry, large black hole, okay? So a supermassive black hole that is actively gathering in matter onto itself, okay? So producing so much radiation that outshines everything else, and there's this black hole that's doing it, okay? And you guys are like, okay, so it's a black hole, right? Black holes aren't supposed to produce light, right? They're supposed to absorb it. So how is it that this black hole is causing all of this light to be produced? So this diagram here is kind of a cartoon of what a quasar is. It was made by Meg Urey, the head of the physics department at Yale, who's one of the top quasar scholars. So here's the black hole here in the center, and here's all the matter around it, okay? So what's happening is all of this gas and dust around this black hole is trying to fall into it. But it all can't fall into it at once, right? So just like the water in your sink can't just fall down the drain, it swirls round and round. This is the same thing, except tons of gas and dust are trying to fall into this black hole. Okay? So if you're a physics major, right, it has a bunch of angular momentum, right? It has to lose that angular momentum before it can fall into the black hole, right? So the stuff towards the center is moving faster, and the stuff towards the outside is moving slower. And so all of it is rubbing against each other, producing all this friction, which causes it to glow. And that's what creates all that light. So all this stuff around the outside is glowing very, very brightly, outshining the rest of the stars in the galaxy. Okay? Now these things here, these are the X-ray beams coming off it, and there's radio waves produced and all that sort of stuff, which is very cool. And we don't know how it works yet, and it's a very interesting project, but I'm not going to talk about that because that's not my research. But it's there in the diagram. Okay? So, in case you aren't convinced yet, alright, one sec. You guys want to see all this?